Hey everybody, welcome back to Business Intelligence. I hope you're doing well. I'm happy to start this remote session to replace our face-to-face class because, as you know, we're in this crisis of coronavirus outbreak. Although the time is difficult, I hope that everybody will be encouraged because I'm here. Whenever you have a question, I can help you. And with today's technology, we can go through this difficult time. Keep the spirit up. As you see, I'm wearing red, and this is UH color. I hope this will cheer you up. Also, everybody's situation is unique. I'm working from home, as you can see. You can't see that I'm actually in my bedroom, but we'll keep the class. We'll continue with the class, and we'll do whatever we can. I will do whatever I can to help you to keep this course as live as possible. Also, do whatever you can. Push yourself really hard to continue. And as a student, you have all the resources available to you. I will help you, and we together as a class will help each other. We'll make use of some of the Blackboard tools that we have never used, including discussion boards and other digital tools to help each other go through this difficult time. If you have other difficult situations that you're dealing with and you need help, don't hesitate to let us know, and everybody will try to be creative. I will be creative to deal with these different difficulties. Some of these are quite unique, as you know, because this is an unprecedented time of coronavirus outbreak. And this is the first time that we're being tested, and hope we can do well. I hope I can do as well as you do in this class. And even though this is the first time that we're being tested. Okay, now the purpose of this video is to cheer you up by showing you that I'm here, I'm with you. I'll do everything I can to help you. And I'll talk about how the course will be affected and going on, how I am going to structure this course, and how I am asking you to help me help maintain the rhythm of this course to help us go through the difficult time by continuing the delivering of this course. And I will talk about the exam. I will talk about the first exam that's supposed to happen on Monday. And if you're watching on Monday, then exam 1 was supposed to happen today on this Monday, but it will be postponed for a week. As you know, this entire semester is postponed for a week in order to prepare the class online. And after talking about exam 1, I will talk about the content that's supposed to be in this week. And, as I'm showing here for this week, other than reviewing exam 1, I should talk about neural network, a very exciting topic and quite important chapter of the semester, as well as a very important and useful tool, modeling tool that you should leverage in doing your project. So the homework for this week would be, not for this week, but the homework for neural network will be quite important for you to practice how to use neural network and get a better understanding of the content. So that is going to be the to-dos for today. Now, let me talk briefly about exam 1. Usually, exam 1 happens in a classroom. The duration is 90 minutes. Now, since we are doing this course remotely, as with every other course, exam one obviously cannot happen in a classroom, but it will still be on a computer and open to book. Traditionally, in the classroom, I would prohibit using internet because you would have all the resources anyway. You can make use of the book. You can use any notes that you have. You can use slides, and most importantly, you can use the electronic PDF version of the book if you prefer to do that, because that would give you some search function, and sometimes if you want to do a copy and paste, you can still do that with the digital book. So that gives you some benefits of doing that. And since we're doing it remotely, I will allow you to use the internet, and you don't have to use the internet. And for the purpose of this exam, I don't really see particularly big benefits of using the internet, but just in case you need it for some help needed on the fly, you can still use that. So according to the emergency syllabus, exam one will take place on Monday of, should be March 30th, beginning at 6 p.m. Our usual classroom time, until 7:30. The duration is still 90 minutes. You'll do it on your computer at home or everywhere that you have internet access and access to computer, and you will need Microsoft Word to compose your answer. At the beginning of the exam time, it will open up. Exam will open up in Blackboard exam page promptly at 6 o'clock in the afternoon. You can download a Word. Document containing the exam one questions. All the questions will be short answer. Compose your answers in that Microsoft Word file that you downloaded, and save your work frequently to avoid losing your work. And make sure that well before the exam closes at 7:30, make sure to save your work, upload your Microsoft Word document with your answers back to Blackboard exam one item. Make sure that it did upload successfully before you close the browser and leave the exam. And exam item will disappear promptly at 7:30. I hope no surprise will come up. Make sure that you are prepared. You have all the equipment. You have all the resources available to you, physical book or digital book, regardless of which format you want to use, any notes that you want to use, and slides, etc. I'm sure that you might have some other questions, so I have opened up the discussion boards in addition to monitoring my emails. Whenever you have questions about exam one between now and next week, make sure that you make use of the discussion board and or email me the questions about exam one. I would say a better resource to use is the discussion boards, because your question might be similar to other students. If you ask the question and provide answer in the discussion boards, other students would not need to ask that question through email. That would free me up more time to be prepared for later parts of the semester, and so that I can make more useful resources, including videos and notes and comments and announcements, and as well as responding to any emergency emails to you. So that would conclude my comments about exam 1. In terms of what is covered in exam 1, it should be clear once you review the exam 1 review document, upload it to Blackboard. And if there's any inconsistency between the policies of exam 1, what I just said in this video will rule. What I announced in the announcement page under the emergency situation will also rule. Any other inconsistency should be disregarded, and the announcements made under emergency and as well as in this email will be official. Okay, this part is about homework 5 and regression. Okay, now I'm going to talk about homework 5, which is due this week, or the revised schedule of week 8 on Wednesday night. So homework 5 is about regression. And before I talk about what is in this homework and to talk about a few important things in completing this homework, I will before I talk about those, I will talk about regression, and to finish off what I haven't talked about in the week before we had the spring break, to hopefully give you a refresh of the content. And now you can see that I have switched into the dual screen mode. On the bigger screen, you will see my desktop. I will talk about some concepts and demonstrate the software, while you can always see me in the corner showing a little camera of my face. So in the whole time you can still see me, so I'm still here. So hopefully this gives you a little bit more spirit. And as usual, I'm wearing red, the UH color. Okay, now so the homework 5 is about regression models. During the week before the spring break, I briefly talked about regression. Well, actually talked about a few things about regression. And I demonstrated a few regression models, including the stepwise regression, particularly the forward selection regression and how that works. And also I demonstrated how to use the model comparison node in SAS to compare the model performances between regressions, or several different regressions, with the descending tree model that was trained before. So here I'm going to first talk about a few important things about regression, or to bring your memories back to some of the important things about regressions. I'm going to skip a few slides and okay. Now, so regression, the name of regression actually, it comes from a very interesting story, but for the sake of time, I'm going to skip the slides, and you guys can read about the story in the slides. But basically, regression in its simplest notation, let me bring up this slides. In the simplest form, regression is this line where the x variable is on the x-axis, is used to predict the y variable on the y-axis, and in the basic format, regardless of whether or not there is only one predictor variable or more than one predictor variable, the regression model is always a straight line navigating the space of the possibly multivariate x space in predicting the variables, the values of variable y. So, in this graph, it is a simple linear regression where one x variable mid-parent height is used to predict X variable mid-parent height is used to predict one dependent variable Y, which is child's height. In other words, here parent's height in terms of inch is used to predict child's height in inch, and so they're the genes that regulate the height of the unit is it tend to be consistent and share the same components of the gene. So this is the basic formula of regression, and in the math notation, dependent variable is y, and the independent variable is collectively noted as x, where if there are multiple variables, it can be x1, x2, and x3. Here is another variable where you can see that the x variable is sugars, and the y variable is ratings. This is actually the the data set for homework 5. The dependent variable or the target variable in machine learning notation is the rating of a cereal product. The data set is a collection of cereal products with different manufacturers and other nutritional ratios, as well as a third-party rated rating of nutritional rating of the cereal product. So here, a scatter plot is made between the dependent variable rating and the independent variable sugars. If this regression only has one independent variable, sugars, and plus a constant term here, which is a constant term that takes value of 1 for every observation, and the coefficient being estimated is the intercept, right? And the only one predictor variable here is the sugars that can take various values between 0 and 15, which is grams of sugars, between 0 to 15 grams of sugars, depending on which level of sugar content the cereal has. The rating of the product does vary. So based on the dots that are scattered on this plot, you can fairly easily figure out a trend, a downward trend between sugars and ratings. As sugars increase, rating tend to decrease, and this conforms to conventional wisdom about the value of a product depending on the sugar content. And in the regression framework, if you estimate a regression model of ratings based on one predictor variable sugars, you'll get this best fitted line, which is this blue line that is the least squared error regression model that depicts or captures the linear regression or linear relationship between sugars and ratings. Excuse my phone. Even in this desperate time that scammers are trying to leverage their technology to try to scam you. So I got I can't say that I get more robocalls, but I'm definitely not getting fewer robocalls. So every day. Homework 5 has several hands-on questions that ask you to create models of regressions. One is simple linear regression, the other is multiple regression that involves 2 variables. Okay. So how to interpret the results of regression regression output. I will demonstrate how to get the reports and how to find the specific parts of the reports that will be useful for answering questions in homework 5. But here, you know, let's say that you have found this. Let me change this to a pen, and so that I can write on this board. And can I change color? I don't like red. I don't like red on the slides. I do like red. Let me use blue here. Okay, so on a typical regression output, you'll see a section of coefficients where the coefficient is listed here that corresponds to the betas that you see previously, and each of the beta will correspond to a predictor. Sugar is the real predictor here. The constant term is the intercept. You also see you'll see the coefficient estimate, as well as the standard error coefficient of the beta coefficient, and there's some statistical testing results accompanied there. So how to write out the regression equation based on these results. And in a simple linear regression scenario, you should be aware that there is only one x variable here. In a simple linear regression, there's only one variable here. It's sugars, and sugar in this format would correspond to the x variable here, and the constant would correspond to this somewhat a hidden y, a hidden 1 sort of. There is a hidden 1 constant. It takes a value of 1 for every observation in the data set, and it's timed by it's multiplied by the beta now, which is the intercept coefficient. Together it becomes the intercept. So the constant refers to that. So this value doesn't change, and it is used to estimate the overall average of the y variable here, which is the intercept. Is where the intercept value means where the value where the x the value where the regression line intercepts with the y-axis. That is when the x variable takes a value of 0. Let me go back to regression. This is the intercept, and it's should be close to 59, right? 59. And if you extend the line, it will meet at 59, close to 59 here. And this intercept value is the predicted value when sugar, actually it's here, when sugar, let me clear that, and this is a point where the regression line will meet the y-axis when the x variable sugar takes a value of 0. So this is the actual meaning of the intercept coefficient estimated here, which has other name. The other name is constant. Okay, so B0 will point to this value, and this is why the regression equation will be rewritten as 59.9, which is approximately 59.853 if you round it to 1 decimal point. And here, so the sugar corresponds to the x variable, and the coefficient for sugar is minus 2.46, something like that. So that's why when you substitute x with sugars, and the coefficient for sugars minus, including the minus sign, minus 2.46 is the coefficient of the sugars in the regression equation. So this is how the equation and the regression output will correspond to each other. In terms of hypothesis, this will not be required in currently for this course, for this semester, but it might be useful to know. I believe some of you have taken the basic the business analytics, the stats course, and over there hypothesis testing should already be talked about. So I would simply briefly mention that. Feel free to review the book and in the relevant chapters to refresh your minds about hypothesis testing. Okay, so in SAS output, it will look something like that. Here, and let's do a laser point. Regression output in SAS will look something like this. You'll look for the analysis of maximum likelihood estimates, because the actual algorithm of figuring out the optimal estimate for the regression coefficient is the maximum likelihood estimation method. Given the model, in the case of a simple linear regression, there's only one x, and the x is fiber here. For now, ignore the log for this log part is because the fiber variable is logarithm transformed, which you already know how to do that. But it's not necessary that you do that. I will talk about specifically about that shortly. Okay. So you'll find the coefficient estimate here, and suppose that the coefficient result is b0 and b1. b1 is for the input variable. b0 is for the intercept. And how do you interpret the specifically? Most likely, you'll be asked to interpret b1. How to interpret the value or the meaning of b1. And here it is. Let me change it to pen, and let's make sure it's also blue. Okay. So how to interpret the slope coefficient b1? Let's say if b1 if the value of b1 is 1, the meaning of that is whatever unit scale is this variable, regardless of if it's log transform or original format, you would interpret with the scale that is being used in estimating the regression model. The meaning of the coefficient is for every 1 unit increase in this variable, rating, which is the dependent variable or the target variable, rating will increase if b1 is 1. If, let's say, b1 is 1, then rating will increase because its sign is positive. b1 will increase by 1 unit, will be increased by 1 amount, and this amount should correspond to the scale of x. If the scale of x is log transform, then you should state the log transform scale amount 1. If it's not log transformed, in other words, if it's in the original scale, let's say fiber, which typically is in the scale of if not log transform scale. Clear that. Scale is typically milligram. So here, for every 1 unit increase in fiber, rating will increase by 1. So some correction. The scale of fiber is actually correspond to 1 unit increase in fiber. So 1 unit increase means 1 milligram increase in the original scale of fiber, if that's not log transformed. And rating will increase by 1 amount, and that amount will correspond to the scale of rating, which is typically in points. So 1 point of rating. So that is how you would interpret. That's how you would interpret the meaning of the coefficient. And here, let's do another exercise. If let's say that you are asked to estimate a multiple regression with 2 variables, x1 and x2, and then x1 would point to sugar, and x2 would point to sodium, and you have obtained their regression results. So how to interpret the meaning of the coefficient for sugars? In a multiple regression situation, whenever you interpret the results of one coefficient, one regression coefficient, you would always be sure to include some language like this, with everything else equal, meaning by keeping sodium and everything else, in case there are other independent variables, with everything else equal or controlled, or some language like that, with everything else equal, with 1 unit increase, and here it's always increase. Whenever you interpret the coefficient, the hypothetical change in the x variable is always increase, with 1 unit increase in, let's see, sugars. And here sugars variable is in its original format, so sugars should be gram, with 1 unit increase, meaning increase of 1 gram of sugar. Rating will, whether or not it increase or decrease, will depend on the coefficient here. So sugars should lead to higher sugars should result in lower ratings, as reflected in the estimate of the negative coefficient here. Negative coefficients here. So rating will decrease by how much amount? By decrease, since I have written decrease, so that there's no need to put the negative sign here. Would decrease by 2.39. What is that? Let me clear the so 2.39. 2.2. You can round it to 2 or 1 decimal points by 2 points. and I am not sure why that always disappears. Okay, so this is how you will interpret one of the coefficients. With everything else equal, and with 1 unit increase in sugars, rating will decrease because it's negative sign, will decrease by 2.39 points. This is how you would interpret the coefficient completely. Okay, I believe with that said, you should be equipped to start homework 5, and let me talk specifically about homework 5. Alright, now let me talk about homework 5 specifically. Now homework 5 has 5 questions. All of them are hands-on questions, as you can see. Beginning exercise 11, they're all hands-on analysis, and it makes use of a data source called serials. Actually, you can download that data set from Blackboard, and the specific questions are 11, 12, 20, 21, and 22. 11 and 12 asks you to estimate the regression that's stated here. So question 11. First of all, you will estimate a regression. Use a regression to estimate rating based on fiber alone. So you should only include fiber in the equation for this question, for question 11. And after you get the results, you should interpret the slope coefficient as I explained earlier in the slides. Explain or interpret the coefficient estimate for fiber in this simple linear regression. And for question 20, be sure to read the question in this part. Do the following exercise based on this description. Use multiple regression to estimate rating based on 2 variables, fiber and sugar. So now one variable is added to the regression. It becomes a multiple regression. So your variable should include 2 random variables, sugar and fiber, that is previously included. And it asks you to estimate the regression. Again, you will model the regression as a separate regression model. Use another regression node. Don't mix them up in one regression node. And after getting the results, interpret the coefficient for fiber again. So it's again fiber, but because this time it's multiple regression, you will include the additional notation, additional language in the interpretation of coefficient, which is with everything equal, or with everything kept equal. Right? Hopefully that doesn't create any confusion. And the last question is to compare the R-squared between the 2 regression. In the first case, it's simple linear regression. In the second case, it's multiple regression. And observe what happens to the R-squared, which is the slope of coefficient. And what is the R-squared? Let me quickly refresh your minds about that. The R-squared here, as you can see, in the output of regression, besides the slope coefficient that you get, you also have a section that notes the analysis of variance and the R-squared coefficient of association. R-squared sometimes is is shortened as RSQ, R-squared, and R-squared adjusted takes into account the number of input variables being modeled. And the R squared here is 70.8%. R squared is always between 0 and 1, or between 0% and 100%. And the reason why, I'm sure you probably has been familiar, or otherwise, please refer to the textbook, the relevant chapter in regression, to read more about the R squared. So here you will answer the question of how did the R squared change and why is this happening? Okay, now a couple things to note here about this homework, and I will bring up the my SAS Enterprise Minor. So the first thing to note is that the data source for this homework is serials. So you would and this is the new data source you would need to download from Blackboard. And in my SAS library, it looks like this, and it should look similarly as you would have. It's serials, and you would create this data source. And also for the homework's sake, because this serials data set is the first time that you analyze this data source, you would include some demonstration and explanation about setting up the project, including bringing in the data source and how you specify the how you specify the properties and roles, levels and roles of the variables here. And I note that because the questions, considering all the questions of homework 5, it also involve 2 or 3 variables. So you probably would wish to reject most of these variables in the list, right? So I would suggest that you can reject all of them and only retain the useful ones. And here the relevant factors, variables here should be the target variable rating should definitely be there, and rating is here, and it definitely should be the target variable, right? And the rating is in interval level. And the first question asks you to make a simple linear regression model with, I think it is fiber. You would definitely include fiber as well. And, study the documentation information in homework about the variables in fiber, the variable about fiber, carefully select the level of fiber. Also, the second group of question asks you to include a second predictor variable, which is sugars. So you would definitely also include sugar, but you would need to click and reject everything else. So to streamline the process, I would suggest that you can holding down the shift, holding down the shift key, you can select multiple variables, and while those are selected, by changing the role of one of these variables, it will change for everything. And then you can bring back the variables that you indeed would like to include. Here it's the fiber, but deselect all of them to avoid applying to all the variables. So it should be input for fiber, and same thing here. I'll select multiple of them, reject, but then only for sugar I will change it to input. And one last thing, if there is a column that can qualify as ID, you should always do that. and here something that is unique for every row for every observation. It should be the name of the serial number, the serial product, because the name is always unique so you would also convert it to the row of name to ID, and as everything is unique, the variable is a nominal key, is a nominal level. Okay, that should complete the configuration of this data set, data source. Right, so that's good. And a couple more things to note, I think. So let me bring a blank canvas here, a diagram. Let's see, homework 5. Serials. So a couple of things to note here. Because this is a new project, this is the first time that you analyze the serials data set. It's highly advised that you would do the exploration and diagnostics analysis of the data source in every crisp DM process, right? So the node to follow immediately after the data source is the stat explorer, and you should take a look at the summary statistics inside the stat explorer after you run it. And I would also suggest that you do multi-plot in order to quickly analyze the relationships between each of the input variable with the target variable, and because all of them are most of them, including ratings, sugars, and fibers, they are continuous variable or interval variable, and you would instead choose to plot scatter plots between those interval variables, because bar charts would not make much of the sense here. Bar charts are mostly suitable for binary or nominal target variable, but here it's interval target. And other than that, something that we also typically do is to take a look at the overall distribution of all the variables and recall that which node we use to do that, to quickly generate histograms or bar charts for all the variables without even having to generate all of them. It is transform variables, yes. So it should be under modify, transform variables, can quickly analyze, and I would put it here. This is not the main line of path, but I would digress into another main line, but here it's mainly for explorations. Let me tidy up the graph. Okay, now here, because it's a supervised learning model, regression model, even though the homework is fairly simple, I would also suggest that you use a data partition node to partition it into at least two parts, the train and validate part, in order to facilitate the model comparison node. Here, but do that only after you have explored the data set. Okay. Also, I should remind you that this data set does have some problems here, because there might be some missing values here, so you would definitely want to make sure that you do stat explore and to rectify the missing value problem if you do find one, and to impute the missing values, you would do the imputation here, the impute node under after you have done the stat explore. And but before you modify any of the variables, the best practice is actually to do the partition here. So under sample, you should do data partition, and follow that with impute if you do find missing values, and whether it is indeed optional to do transform variable. As I mentioned, the interval variables tend to sometimes have skewed distributions. So if you have a distribution, highly skewed distribution, then this tail part would probably create a lot of trouble for your model. Will lead to the error to be higher, especially in this region. So the best way to do that would be to use transform variables to and specifically to do logarithm transformation to fix the skewed distribution, as I talked about in the class. That said, it is not necessary to apply z-score standardization or range standardization or min-max standardization to standardize the variables, because regression is robust to the scaling of the variables. So the original scale of the variables will not include bias into a regression model. It does change how you interpret the coefficients, though. If the scale is changed, the coefficient size will typically change. All right, so and the last one would be to use regression, the regression model. And here you would use a regression model after you have fixed all the problems with the data set. Okay, so and recall that the first set of questions asks you to do a regression with only one input variables, and the second set of questions asks you to do a multiple regression with 2 input variables, and in that case you would actually need to do 2 regressions. So the first regression would you can first regression or simple regression or simple regression. It's actually too long, so it doesn't allow me to save the simple regression, and you would want to make sure that only the fiber variable, let me make sure, that this only the fiber variable is included, fiber alone. So in that case, what you can do is you can change the variables. There is a variables node here. You can make sure that only the fiber variable is included or is enabled in this regression in order to correctly estimate the model. As you can see here, all the the use column of everything, every predictor variable is default, and default means to apply the settings that is inherited from the upstream path, and those will be rejected. And the only predictor variables that have a role of input is fiber and sugar, and also as well as the ID column, which is the name. And name is not shown here because it's ID. So you want to make sure that only fiber is enabled, and you can keep the default, which means to accept the role of input. But for here, sugar should be changed to no, which makes sure that sugar does not enter the regression here. So that would be good, and the path is being updated, and that would answer the first set of questions. And for second set of questions, you would need another regression side by side with the simple linear regression, and to denote a multiple regression. And here, you know the drill. There is no need to actually change any of the setting here, because you would need to include all the input variables that have the input role, and everything else that is not needed has been rejected from the beginning part. And so after at this point, it should be clear that this is not the only way to do that, right? You could accept, keep the default and accept all the variables at the beginning, but here select only to use the fiber as the input, and here select to use only fiber and sugars as input, and reject or change no, and use and select no for every other input variable. These are the two ways that you can do that. So that should be it. The way to get the reports of the regression models, I'm sure that you have already learned how to do that. I've already demoed how to get the results from regression models in the week before a spring break, and also it is make very good use of the previous semester's videos. I'm sure the video 8 from previous semester, or from previous 2 semesters, or week 7 and week 8, they either both of them or the week 8 video of them in the previous semester talk about homework 5 also, and talk about regression models in good details on how to get the results, and how to read the result output in SAS. So have fun with doing homework 5. Questions, if you have any questions, feel free to email me, and also I will very soon create a discussion board for homework 5 specifically, or maybe I have already done it, which is great. So make sure that you voice the questions about homework 5 in the discussion boards, and just another word, discussion boards should only be used to communicate confusions or clarify about the general questions about the homeworks and any other items, including the exam. It is not a place to share the results. And let's be fair, how much you retain, how much you learn about data mining, and about SAS, and about the homeworks and the models is directly related to how much you put in. If you simply copy other people's solutions, you would not virtually learn anything. You would learn how to copy, and that's it. So I strongly suggest that you do not ask for questions and solutions and simply turn it in. The point of doing homework is really to push you to think about and learn the stuff that you haven't learned. And homeworks are made already to a minimal level of essential points, so they really help you to get a minimal amount. I would really be happy to see that if you push yourself to read the book more closely and learn the stuff that are not required in homework, which should go a long way in helping you be a better machine learning analyst or data analyst. Okay, so that's all about homework 5. Next, I'll talk about briefly about neural networks, noting that we also have another week of neural networks, so I will not go into too much of the details,